Hello, everyone. I'd like to give a high-level overview of my solution for the Inundata, mapping floods in South Africa competition. This competition is a binary classification problem involving both tabular and image data. The evaluation metric used was binary log loss. The dataset itself is relatively straightforward. We were provided with two tabular data files, train, CSV, and test, CSV, along with corresponding images for each location. As you can see on the leaderboard, the scores are quite low, suggesting that many models performed well in predicting the outcome. However, this is also influenced by the unbalanced nature of the data. So my solution is based on a simple XGBoost model. I started this competition with a basic rule-based model, using just the location and the day. Then, I began building a cross-validation pipeline and used XGBoost as the binary classifier. For cross-validation, I implemented a grouped stratified k-fold. Without any feature engineering, I achieved a log loss of 0.00421. A key feature engineering step I found was building the rolling mean of the precipitation column. I experimented with various window sizes, from 2 days to 240 days, and this further improved the score. When applying the rolling mean function in pandas, a crucial hyperparameter is center equals true. My understanding is that this centers the window of the rolling mean on the current data point. This allows it to capture precipitation data both before and after the current day. Another key feature I found useful was computing the lag feature, or the difference feature. This is essentially the difference between the precipitation on the current day and that of a previous day. And then, we can also compute the rolling mean of this difference feature. This is a very powerful feature as well. In step 6, I think this is the most innovative thing I did, a Gaussian smooth label regression model. The core idea is that the labels we have for the data are one-hot encoded for each location. So, for the 730 days of each location, if there's a flood, only one day has a label of 1. This makes the problem very difficult for the model to learn, because there might be multiple days with heavy rain, making it challenging to identify which day the actual flood event occurred on. The idea behind the Gaussian smooth process is to transform the one-hot label vector into a smoother, floating point vector. This allows us to train a regression model. You can imagine that in this transformed vector, there are multiple values of the label that are non-zero. The mean of the Gaussian is clearly the flood day, and the variance is a hyperparameter we can tune. We can then train a regression model instead of a classification model. And we can use the regression model's outputs as the base margin for the classification model. Since we're using XGBoost, the base margin will be the initial predictions for the training, validation, and test data. I found this to be a great way to help the model focus on a broader region rather than just a single day for each location. Lastly, I fine-tuned a pre-trained YOLO model to perform image classification, allowing us to classify flood locations versus non-flood locations. For the flood locations, we can apply probability normalization, which helped me achieve my final best score. I'll go over each step in more detail and release the code in the next few days. Thank you.